Hey, folks, let's just pretend for a moment that we are decision makers for a company. And our company has decided that we want to make better decisions. We don't want to just go by our best guesses and our gut feel and what we think based on experience. We want to use data to improve our decision making. We want to know based on real factual evidence what makes our company more efficient, what makes our company more profitable, what makes our company, at the end of the day, more money. And we want to use data to drive decisions. And so we want to start doing work on building an analytics solution. Now, let's also imagine that we know that there is a whole world of technologies out there that make up an entire stack of technologies to get from our source data to being able to get these analytics. And at every layer of this stack, there are competing vendors, the big cloud vendors, Microsoft, Amazon, Google, in addition to other vendors that are competing with these at every layer. And there's all kinds of claims being made by all of these products, and we don't really know which ones are really, really legit good facts about these things and true claims, and which ones are radical exaggerations. So let's start by taking a look at a couple of these products. And we're going to look at a couple that should be fairly comfortable to most business users. Most business users have worked with dashboarding and reporting technologies, so these things should be somewhat familiar to all of us. We're going to look at Power BI, which a lot of us have already seen, and Sigma, another competing product that does a lot of the same things. We're going to look at the claims that the vendors are making and what that really might mean to, do they really do what they say? And does it cost an amount that we're not going to be willing to spend? Because at the end of the day, all of this building a solution for analytics can get to be very expensive, both with the technologies on-prem and in cloud, as well as labor costs. So we want to try to control all of that and not spend foolish money just by blindly following vendor claims that may not really be a fit for what we're doing. So let's get started looking at those.
Born in the cloud, Sigma is an analytics platform that works like a spreadsheet, but with unlimited scale and superior governance. Users access Sigma through their web browser without installing any software. You can get up and running in minutes. The familiar spreadsheet interface auto-generates SQL and uses it to live query your cloud data warehouse. Sigma doesn't store your data, so your security team will love it. And performance is fast, even on large data sets. Sigma leverages the massive compute power of the cloud data warehouse, accessing billions of rows of data. So how does Sigma work? Let's suppose I'm a category manager at a retailer called Plugs Electronics. Our big initiative this year is to increase margins. I have access to historical sales data in my cloud data warehouse, which is about 4.5 billion rows. Way too big for a spreadsheet. Since I manage the photography section, I'm going to begin by filtering my data. Sigma works like a spreadsheet, but we're looking at live data from the cloud data warehouse. The spreadsheet interface lets me write a formula to calculate the profit for each transaction. Then I can group by brand to see total profit and calculate gross margin too. No SQL required. I'm able to get the latest answers myself without going to an analyst and waiting for results.
Okay, well, that certainly did look impressive. 4.5 billion rows of data, and it was very snappy, very fast. They appeared to give all the credit for that performance to Sigma, the reporting and dashboarding tool. But let's unpack what we just saw a little bit, see what it's really doing under the covers, and see if this really is what's going on. Now, it looks like they're using Snowflake as their cloud data warehouse for this demonstration. A comparison of cloud data warehouses and why we can settle on the fact that this appears to be Snowflake is outside the scope of this video, and we'll cover those details in other videos. But for right now, let's just say that it appears that this is Snowflake and kind of dig into what's going on between Sigma and Snowflake. Sigma's initial direct query call will go to Cloud Services for the Cloud Data Warehouse. The Cloud Services will spin up a virtual warehouse to actually perform getting the data for the query. The virtual warehouse will make a call to get the data from remote storage. The remote storage will send the data back to the virtual warehouse. When the virtual warehouse gets the data, it will send that data back to cloud services and additionally throw it into cache. The cache in this case is referred to as result cache, and it will hold onto the data from this query for 24 hours in case another subsequent call comes in that matches it exactly. The data is then returned from the cloud data warehouse to Sigma, and Sigma presents the data in its reports and dashboards. Okay, here's where things get a little bit sticky. This whole process of getting all the way from the reporting and dashboarding tool to remote storage and back again for 4.5 billion rows isn't typically sub-second. In fact, a call like this, you're looking at more in the neighborhood of probably 15, 20 seconds per result, per click, per drill through. Everything that you do is probably going to have that amount of latency for that size of data using direct query. Yet this video didn't seem to show that. So what's really going on here? Let's look at that. To get at the underlying magic that appears to be going on in this video demonstration, we have to look at what happens when there's a subsequent call. After those initial calls and that data has been thrown into the results cache, what happens if we make an exact identical call again within 24 hours? In this case, Sigma makes another direct query call to the same data warehouse. In this case, the call goes directly to results cache without ever touching a virtual warehouse or remote storage in any way. That data is returned from cloud services immediately back to the reporting tool, which means it's sub-second, it's virtually instantaneous. Okay, so what does all this mean? Well, it means that there is in fact some magic going on here. The problem is none of that magic's actually occurring in the BI reporting and dashboarding tool. It's all happening behind the scenes in the cloud data warehouse. In this case, in order to make your demo look incredibly fast and impressive, all you have to do is run through all of those steps before the demo starts and then rerun through them exactly the same in the demo, and everything's instantaneous. But it's not necessarily because direct query in Sigma has some magic properties. It's all occurring on the back end because that happens to be the data warehouse that you're using for your demonstration. Now, we're not trying to look at data warehousing platforms in this video. We're looking at dashboarding and reporting interfaces. And the behavior that we're seeing right now with Sigma and direct query is going to be exactly the same in any number of other dashboarding and reporting interfaces. But that's not to say that there aren't other capabilities that are possible. So right now we're going to take a look at another interface. Next, we're going to look at Power BI. Now, it's important to notice that Power BI has direct query mode and would behave exactly the same as Sigma. In other words, you've got the first initial call to Snowflake and then subsequent calls that are going to behave completely differently if they're identical. Against any other data warehouse, Power BI in direct query mode is going to behave exactly like Sigma. However, there are other capabilities that you need to be aware of when you're looking at tools for doing dashboards and reports. Let's look at Power BI now and some of the capabilities that it does offer.
Power BI Premium offers dedicated capacity for your enterprise or team, enabling data volumes up to 10 times larger than before. What that means is self-service, real-time analytics against massive volumes of data spanning up to hundreds of millions of rows. Let's see what that looks like. So here I am in the Power BI service. I'm looking at a report built on top of a dataset that's hosted in Power BI Premium capacity. Now this is a truly massive amount of data. There's one row in this dataset for every single taxi ride that happened in New York City since 2009. Let's see if we can get some interesting insights on this data. So I'm going to go over to this new report tab, and first I'm going to see just how much data I'm working with. So I'm going to drag in the trip count measure, and here, turn it into a card, we'll see that we have over 520 million trips in this data set. With the power of premium capacity, I can go ahead and start getting insights right away. So first, we're going to see, for example, how revenue per trip varies based on trip duration. We're able to instantly build that visual. And here, this visual tells us that as revenue per trip increases, so too does trip duration. We can keep going. For example, we might be interested in how revenue per trip varies over different zip codes. And just notice how quickly I'm able to build these visuals. And with Power BI, you can cross-highlight, clicking between the different visuals to find out the relationships in the data. It's an extremely snappy experience. It really feels like I'm working with 500 or 5,000 rows of data, not 500 million. Now, in this particular visual, we see something interesting. There's 2 zip codes with far and away more revenue per trip than the others. Let's try and find out why that is. What I'm going to do now is build a map of New York City and plot all of the taxi cab pickups against that map. So I'm going to make the map, make it real big, and here I'll put in trip count, latitude, and longitude. And we're able to see instantly a map of New York City with the taxi cab rides plotted on it. Now with cross-highlighting, I can finally get to the answer of my question. It turns out that these 2 zip codes with the most revenue per trip are actually the regional airports of New York City.
Okay, when looking at Power BI, it's important to note that there are different storage modes. These are things that you need to be aware of when you're building your solution for analytics. First of all, there's direct query, which is what we've looked at up till now. It's going to behave exactly the same as Sigma and any number of other different dashboarding and reporting tools. This is basically going to run real-time queries against your data warehouse. These queries need to not be overly complex because complexity can make things sluggish in direct query mode. It's important that the data warehouse be fast enough for a good user experience. For licensed users, there's no additional expense for going against the data warehouse for these queries in this mode. Next, we have import mode. With import mode, Power BI uses dedicated tabular storage to hold all of the data for all dashboards and reports. The data is 100% dedicated in memory, it's compressed, and it's very fast. In import mode, you're never waiting on the data warehouse to retrieve and return data to you. The data as a background process is periodically refreshed to Power BI and always available within Power BI with no need to connect to any other data source for the data. Power BI allows us to import data directly into the Power BI service with no additional components required. This means that we can go directly against Power BI's database for all of our data instead of waiting for an outside data source. There's a problem. It's limited capacity. They will only allow so much data. Microsoft only allocates so much memory for your in-memory data, and there's only so many refreshes that are allowed. In other words, you're not going to be able to import data every hour, for example. Microsoft has a solution for this. It's called Premium Capacity, but it is a fee-based service, and it is not cheap. The problem, and you'll notice that there are 2 red dollar signs on this slide, the problem is that it's fairly expensive. The entry price for getting into Premium Capacity is about $5,000 a month or $60,000 a year. With Premium Capacity, as you add more and more analytics solutions or your data continues to grow, you can exceed the amount of capacity that you've purchased. That means that your solutions will begin to break, and you can do one of 2 things. Either you can turn on auto scale, which means anytime you exceed that capacity, they charge more than that $5,000 a month for every minute that that's exceeded. And the amount that they charge is on a scale that can continue to grow and grow and grow. Or you can just purchase more premium capacity, meaning that $60,000 a year just became $120,000 a year. Not necessarily a great solution. So premium capacity can be a problem in that it can become expensive, but there are remedies. The first remedy may be to stand up an SSAS Analysis Services tabular model in Azure. Analysis Services uses the same engine under the covers as Power BI, which means you can import any data that you want into your own Analysis Services tabular model and then point direct query from Power BI directly at that and completely get around any limitations of premium capacity or direct query. It will perform very, very fast, scale very large, and will allow you to perform your imports on any frequency that you desire. So what's the problem? It can become very expensive. And here's the reason. In Azure, it's very difficult to get very, very large memory models without adding a large number of CPUs. And they license SQL Server Analysis Services on processor, which means in order to get, let's just say a terabyte of memory on a tabular model, you're going to have to purchase a large number of processor licenses in order to accomplish that. In some cases, this may be the solution, particularly companies that already have some resources in some form of a data center that's on-prem or on some sort of resources that they actually own and license. If you stand up a SQL Server Analysis Services instance on your own on-prem data center, you can install on a server or VM with very few processors and a great deal of memory. Because this is a memory database engine, it uses very little processor and it uses a great deal of memory. This means that you don't have to spend a whole lot of money on the hardware and you don't have to spend a whole lot of money on the licensing to get a very, very large, very powerful solution. We aren't covering any other technologies in any other layers of the stack for doing analytics in this video. However, one thing worth mentioning, in addition to getting SQL Server Analysis Services tabular when you purchase those licenses, you do have the ability to get other components free of charge included with that can be used in other layers of your technology stack used for analytics. These other components can be installed on the same server infrastructure as your tabular database and can be used at different times than the times that you're doing the refreshes when your models are refreshing. I hope you found this information helpful and useful. Don't forget to like and subscribe. Look for additional videos and resources on products and technologies in all layers of the analytics stack. And feel free to reach out with any questions or leave comments. Thank you.